This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 50. Our favorite new features in Ansys Mechanical 2019 R3, and a look at the news and events in the Ansys and PADT worlds. Hi there, I'm Eric Miller, one of the owners here at PADT and your host for this podcast. I love round numbers, and this is our 50th episode, and PADT is 25, so it's twice as good or something. I'm not a numerologist. I just like round numbers. So welcome to our 50th episode. I remember when we first started doing these podcasts, we didn't know if we'd make it to 10. It's exciting that we're at 50, and so many of you continue to listen to us. So we are hopefully doing something right. Obviously, we must be, because people keep subscribing and keep adding listeners and downloads. So thank you once again, everybody, for joining us. And I'll celebrate in the next podcast when we get to 15,000 downloads. Please let us know. Please let other people know about the podcast. And, share it. Let people know about it. Put it on social media, whatever it is. Tell your cubicle mates. We'd love to get more people listening. So today we're going to jump right into a discussion with Ted Harris and Joe Woodward about Ansys 2019 Release 3. We're working our way through all the R3 stuff for 2019, and we came up on mechanical today. So I'm happy to have Ted and Joe join me, and I'll let them talk a little bit more about it and introduce themselves and talk a little bit about the naming of the releases, because I actually ran into that with a customer recently. So please do enjoy. Well, I want to welcome everybody to join us here with a discussion with Ted Harris and Joe Woodward about what's new in Ansys 2019 R3. And before we get started and you guys introduce yourselves, I do want to reiterate, I actually was on a call with a customer who asked his IT to load the latest version of Ansys, and they loaded R19 and not 2019 R3. So do know that there's a big difference between R19 and 2019. We did change in a year that didn't, we had to kind of go have the same 19 in both. So do be aware of that. But anyway, that's a little aside for those who are listening. Ted and Joe, why don't you introduce yourselves? Ted, you can go first.
My name is Ted Harris. I manage our simulation support group here at PADT. Longtime Ansys user.
And I'm Joe Woodward, lead trainer here at PADT. Using Ansys for 23 years now.
Yeah, I'm not going to say how long, because maybe I should just calculate it and stop, because I really haven't used it as much. I haven't used it on anything paying for a while, so maybe I should just say I have used it for this many years. But I'm excited about this update for a lot of reasons. The biggest is not because there's something in here that I've been waiting for a long time, which is often what I get excited about. It's that they're putting a lot of effort in these R releases, these R1, R2, R3 releases to add a lot of functionality. We're not waiting a whole year for it. And there's a lot of little things in here and some big things in here that I think somebody's going to find useful. So I really like their commitment to continuously improving the software. I always like to start with, what's your favorite, Joe or Ted? What did you see in there that you're like, that's pretty cool?
I'll let you go first, Joe.
I was letting you go first. Let's see. Like you said, there is a lot in here.
Mm-hmm.
I don't know. Personally, I like the command object highlighting. Okay. If you use a lot of APDL and command objects, it goes through and the autofill they added last time around, I think.
Mm-hmm. Mm-hmm.
So now they've added the coloring to the different command highlights.
Great.
Which is kind of something.
So for those that haven't played with it, it's the text editor, right, for creating snippets.
Right.
And we don't call them snippets. Do we call them snippets? What do we call them now?
Command objects.
Command objects. I always liked snippets.
Yeah, I still call them snippets.
That works too.
So we used to have in fact, Matt Sutton, who many of the listeners have heard on this podcast or may know, wrote a tool back before we had that, where he did the highlighting and the autofill as part of the tool, and we don't need it anymore. So it's built into the interface. So it's one of those things that's a huge productivity gain, especially because we're using less and less APDL snippets, right? So as the code gets more capable, so not having to remember those commands is pretty cool. What about you, Ted?
Well, I'm going to pick the new coupled field analysis type. So in the past, if you wanted to do a coupled thermal structural, you had to do some command snippets, some command objects to add the degrees of freedom, add the right loads, and then do some trickery, maybe with renaming the result file to get it all to work. So it was possible to run coupled thermal structural. And by that, we mean tightly coupled, where you're not just solving the thermal and reading the loads in to the downstream structural. You're actually solving both at the same time. We do have customers that have applications where the temperature can change based on position, and that's really where this is relevant. And so this new analysis type has it all built in. So no longer need to do the command objects to make it work.
Cool. And it's a what we call a coupled matrix solve, right? So it's basically adding the thermal degree of freedom with the UX, UI, UZ. My favorite aspect of that, and I don't know why it got me so excited, is the plastic heating. And I think it brings me back to taking paper clips and bending them back and forth, and they get hot.
That's what I thought of.
And so you can model that now in Ansys. So it'll and then your material properties, right? Because as it gets hot, it gets softer. So
yeah, I don't know if you remember it, but years ago I wrote a tutorial on mechanical, just how to get started with it, and that was what I picked was a paper clip. It didn't have the thermal part, but I just was looking for an example that everyone can grasp. Okay, I'm holding onto this paper clip and I'm bending it with my other hand. And it was just a real world example that didn't, require any proprietary parts or anything like that.
Sounds like a good time to revisit that blog post and write it now with the heating.
That's just what I was going to say. Yeah, go back and redo it.
Cool. There was a lot in the user interface. Anything, things like you can now assign colors to the lines that point to stuff, like probes and things, and it seems like you can set your selection color. Anything else in the interface that you guys?
I think for me, one of the big ones is that you can now set your own buttons on the toolbar to basically do, little command objects or the Python coding underneath.
Okay.
But then now, which they introduced last revision, but now you can export those.
Oh, okay. You can share them.
Yeah, exactly. You can share them. You can write them out in the storm somewhere and then read them back in for another installation, so that you don't lose all of those from one installation to the other. Even for us, we have a whole bunch of installations. You can transfer them from one to the other. That'll be good.
Or say your laptop to your desktop. Yeah.
Right.
Cool. Okay. What about you, Ted? Anything on the user interface side of things?
Well, there's the materials view. So at 2019 R2, a new materials view was added into mechanical, but it didn't come up automatically. I think you had to right click to get to it. And now in R3, when you select materials, that view displays by default. And so it's stepping back a little bit. It's something that I think a lot of people had wanted for a long time, which is the ability to specify your material properties directly in the mechanical window without having to go back to engineering data. And if you're using the new Ansys materials data for simulation, the add-on code that gives us access to hundreds of Granta materials from the Ansys acquisition of Granta, this is where you get to them.
Okay. And it shows the graphs and stuff of the nonlinear things too, right? So it's pretty visual.
Yeah, right. Any material property that is a graphable quantity, it will show that.
Cool.
Right.
Thanks.
Another enhancement that I liked that a lot of people probably find reducing your mouse click count is you can go start mechanical directly from the Windows start menu. You don't have to open Workbench and start a project and then open mechanical anymore. You can open mechanical directly read your geometry in there. It's still making the project in the background behind the scenes.
Right.
And in fact, I think it might even bring up the project window as well, but you don't have to go through the project to get there. So I'll speed up the start of the analysis.
That's kind of nice, because I think for a lot of mechanical users, you're just doing a single object in the project, and it's kind of an unnecessary step because you're not coupling things or doing different physics. And yeah, it's a good point. Very good point. I like it. It's probably one of those things that's been on the to-do list for a while, and they finally got around to it.
I think so.
So let's get a little bit more technical, and certainly beyond my experience, because I've never really done fracture mechanics. But can one of you guys kind of tackle the new what's new with smart crack growth in mechanical?
Well, I think Ted has the acronym down.
Yeah, what's it? What is
Ted?
smart? Smart just doesn't mean that it's intelligent. What does smart stand for? Did we lose Ted?
I think we lost Ted.
Okay.
It actually stands for separating morphine adaptive remeshing technology. So it allows the crack to grow through the mesh, and it will remesh as it goes. A long time ago, it used to be you'd have an assumption of where your crack was going to go, and you'd build your model that way,
Right.
so that you could use contacts or whatever in between and have it separate along the way. But this actually, as it does the J integrals and figures out what the next crack direction is going to go, then it goes through and remeshes. So you can actually just grow a crack through the mesh. So on this latest release, they've improved the performance on that. They've parallelized the fracture parameter computations. So all that's parallel now.
Good.
And then one of the big things is that they've added in tabular loading, so that your temperatures and things can be tabular loading over time, or over, spatially varying over your model, as well as your displacements and force boundaries can be all tabular loads now. So that's something new.
It's not just a cyclic load that just goes on until the crack's done. You can actually change that load over time.
Right. And then the other big thing is that you can now put just an arbitrary crack, which they've had for a while. You just specify a surface body that basically cuts into your model.
Okay.
And then it gets meshed around that surface, so that becomes your crack face. But in this release, they've integrated that with an imported mesh from the external model.
Okay.
So if you have an older mesh that you're reading in, you can then just add a crack into that imported mesh and start running.
Which is not uncommon for somebody to maybe even have an MAPDL model from back in the day, or maybe, God forbid, an Astran model or something like that.
Right. So they can take an old analysis. Suddenly they have a crack, and then go back and put a crack in that location and see what the analysis shows.
And have the same mesh, so you can kind of compare apples to apples. Yeah, that's cool. Yeah.
Right.
That is a big deal. Cool. Anything you want to add? Ted's having some Wi-Fi issues, so
he
comes and goes.
There he is.
Did you guys talk about what the SMART method?
Yes.
SMART actually stands for?
Okay, yes, we did.
Okay,
we did. Fortunately, Joe took notes. So
You're right. Exactly.
Sorry, I got cut off for a minute.
That's no worries. It's we have an aging network backbone here at PADT that we're in the process of. I think it found out we were in the process of updating, so now it's rebelling against us. Yeah,
it seems to be going south quicker than it had been.
Exactly. It's like, well, you're doing what? So another thing that we talked about the coupled field. So there's some new things in acoustics, and have either of you played with the ability to take your results and turn it into a WAV file yet?
No, I have not.
No.
Sounds interesting, though.
Yeah, sounds really cool.
I need to I need to find a simple model that I can build and figure out how to do that. I think that would be really kind of a neat thing to do.
Actually, I'm wondering, my daughter's science fair project this year is a Clondy plate, where you take a plate and the vibrations, the acoustic vibrations.
Oh yeah.
To do, show the mode
iron
shapes.
filings, yeah.
Right. Do the mode shapes.
Mm-hmm.
And so maybe I could do that and then see if, make the wave file to see if it comes out with the same tones as
maybe,
what her thing is doing.
Maybe I should model a Fender jazz bass and see what it sounds like. Right.
There you go.
Well, I was thinking saxophone.
The saxophone, yeah.
Have the full CFD structural. It's amazing that Adolph Sachs was able to figure out how to make that thing work 170 years ago or whatever.
Yeah.
There's just so much going on.
So much going on without Ansys. Yeah. So that's a cool feature. As neat as it is, it's also kind of useful, and it gets into the whole idea of NVH, the ability to model what the experience is. Of course, in a vehicle is usually where you talk about noise, vibration, and harshness, but even I remember we designed a hydrogen blower years ago, and we put it all together and we fired it up, and the plate on the back that covered the cooling chamber, it had a conformal cooling, vibrated at just this annoying high-pitched frequency that was excited by the passing frequency of the rotor. It wasn't a lot of strain, so we didn't worry about it, right? Because it wasn't going to fail, it wasn't going to fatigue. But what we didn't realize was how loud it was. It was basically a speaker. Now, and we ended up putting some ribs on it to get rid of it. But that would have been cool to predict in simulation that we can do now. What that would actually sound like.
I think it's clear it's becoming more and more important because devices are pushing limits on efficiency and performance, and when you do that, it tends to get noisy if you're not careful. So having tools that can predict it and help mitigate it are really critical.
And with adding the new motor, what's the new motor tool we just partnered with?
MotorCAD.
Yeah.
MotorCAD, yeah.
So we've got Maxwell, we've got MotorCAD. So we're doing tons more motor simulation, electric motor simulation, and they can be very noisy. And I think that's going to be a positive application when you do your acoustic analysis after your motor analysis and then figure it out. So we also have we talked about a lot in the user interface. There's some stuff in the post-processing. Anything in there that you guys thought was worth mentioning? I think there was something about the ability to do combinations on user-defined results. Was that right?
Yeah, the solution combinations that have been in there for a long time, they finally added so that you can do user-defined results within the solution combinations. Okay. So that you can put in an expression and go and do the user-defined results that you want, but on the combined solution.
Combined results. So combining different load steps, and instead of doing it in Excel, we can now do it in there. Yeah.
Right.
Yeah. It looks like. Go ahead. Yeah.
I was going to say another one is on the cyclic symmetry analysis. You can now use the solution coordinate system.
Okay.
Which in the past, when you had cyclic symmetry, it always had to be in the global Cartesian coordinate system for the results.
Okay.
So now you can, if you rotate all your element coordinate systems into the cyclic coordinate system, the cylindrical coordinate system, then you can get your hoop and radial stresses and things like that.
Okay.
Much easier now.
Okay. That is a useful thing. Again, probably something we've been writing little code snippets for.
Exactly. Yeah.
I always say the best part of these new features is removing the need for people that know how to code.
Putting us out of a job.
Exactly. So anybody want to talk about this new animation with attached camera capability?
Yeah, it's really, and the example I always think of is if you're looking at a room and you throw a ball and you see the ball bounce across the room. Well, the attached camera is a way to focus on the ball, and have whatever's going on pass the ball instead of the ball passing the camera type thing.
Yeah, when we were talking about it earlier, it's kind of like putting a GoPro camera on a portion of your model. And what you're viewing is now what the GoPro is recording, not what you're viewing from, off to the side or far away.
So that is kind of, sometimes that's kind of useful. You want to change your perspective on your animation. So, and for me, it's another example of how they've really improved animation in mechanical recently.
Yeah, I mean, if you have some strange motions in an analysis, to be able to isolate one part and see what the other parts are doing around it can help you, realize what's really going on.
And when Joe does the webinar on this coming up in the near future, there's an animation example that maybe you'll show, Joe, but it shows a 4-bar linkage with two different viewpoints. One is the regular viewpoint where you're looking down at the screen, and another one is the camera's attached to one of the joints in the 4-bar linkage, and then you see stuff as it moves around that point. So it's not quite the GoPro thing that I was talking about, but that's the general idea, is you're fixing the camera to a portion of the model.
Very cool. I want to change gears a lot. In fact, you can use this to model gears. Why don't you tackle, first of all, explaining what general axisymmetry is? I think a lot of users aren't really familiar with axisymmetry and general axisymmetry, and then what's new in this release for it. Yeah,
I think you're right. A lot of users aren't familiar with axisymmetric models in general, because with mechanical, it's so easy to just take your solid 3D model and go for it. But axisymmetric models allow you to have just a 2D cross section of the model and rotate it around a given axis. And in years past, that axis has always had to be the global y-axis.
Okay.
That's been a constraint from
day one.
Ansys's earliest version.
John Swanson put it in there. Yes.
right. If you are going to make something where it's a consistent cross section, and it'll analyze the small 2D cross section and give you the results for the full 3D, but it was always in that y-axis. So now with the generalized axisymmetric, we've been waiting for this for years. You can now pick the axis of rotation, so that if your model is built in, where it rotates around the x-axis, a lot of companies have their their engine, their engine axis is around X. You can now pick that as your rotation axis without having to move your model and all of that. But aside from that, you can also have multiple axes. So as I was telling you earlier, I made a little bevel gear model that is just two little half cross sections that touched along the bevel, and one rotated around the x-axis and one rotated around the y-axis. And you put a force on one, and you see the reaction torques on the other.
Nice.
And it worked beautifully, So you can go through and do these types of complicated gearbox analyses now without having to have the full 3D gears. You can have just simple little cross sections as your first cut, these axisymmetric models.
Right. And if you got a large powertrain or something like that, you don't have to model everything in 360. You can you can model the axisymmetric, and you can have different axes. And so if you make spinny stuff with more than one axis, or maybe your axis, like you said, is not aligned with the global for whatever reason, even if it's just like a power shaft coming off it, 35 degrees. That was always kind of a pain to deal with.
Right.
Yeah.
Or like you said, with a powertrain, you usually have different gears spinning around different axes.
Right.
It makes it much simpler.
Mm-hmm. Mm-hmm.
And even with the explosion of computing power over the last 10 or 20 years, there's still advantages to simplifying your model so that it runs much more quickly with less resources.
Definitely.
Yeah, that's a good point. I think sometimes newer users especially don't think about that. That, if I can get an answer in 5 minutes instead of 2 hours, think of how many more iterations I can do and how many more what ifs and how much more I can get done. Yeah.
Right. Exactly.
Cool. Let's talk let's also talk about component mode synthesis. What's new there at this release?
Well,
Ted, you got that one?
Big one in my mind is that the CMS method is now supported for random vibration.
Right.
So that was a piece that was lacking before.
Mm-hmm.
You can't do an expansion pass, but at least you can do the reduction pass to allow for basically the same kind of thing. A simpler model that gives us a result much faster than modeling everything in great detail. So
tell you if a part is getting really excited or not. Yeah.
Right. So from a top level component mode synthesis, it's basically substructuring. So we're taking components that make up a structure, an assembly, a system, and we're representing them. We're still modeling them and meshing them, but we're reducing them down into essentially master degrees of freedom that represent the structure without the full numerics being there. So it's a way of getting the full effect of the structure while saving a lot in computational expense.
Yeah, and you can still scope your PSD responses to parts that are not condensed. So you can still get those results for your areas of interest but you can condense out all the other parts of your assembly to make everything run faster.
So let's say I've got a mirror for an astronomy or a optics, some sort of optics, so maybe a camera or astronomy, and it's on this complicated gimbal support. I don't have to model to do the PSD to see what the response of the mirror is. I don't have to model all that stuff. I can substructure it and just leave the mirror itself unsubstructured. Is that
right? Right.
Nice.
Yeah.
Nice.
And then for other types, not random vibe, they've parallelized that expansion pass.
Okay.
So for static structural type models, the condensing pass, making each of the components into a single matrix, that's been parallelized. Okay. But then that expansion pass to bring all those results back has also been parallelized this time around.
So if you work on large structures and you worry about vibration, you probably know what CMS is, but if not, do check it out. You may be modeling large complex structures and you don't need to. You may only need to model. You may be able to substructure the whole thing using CMS, or maybe just all the supporting structures. Or because one of the things that you often had to do is kind of make assumptions about what the stiffness of the surrounding structure was, or treat it as rigid. Now we can model that and get a fairly accurate response. So that's really cool.
Just usage wise, they made it so much easier. Just picking which parts are going to be condensed and go off and run it. So
you start with your assembly and you just say which ones are condensed and which ones aren't. And cool. Let's talk then about, we're getting even more, this may be the nerdiest one, what's available with shape memory, nitinol, right?
Yeah.
Shape memory metal.
Well, I can talk about that one. So shape memory alloy is the material model for nitinol. Basically metal that changes shape and then reverts back to its original shape. So a lot of use in medical devices, so stents, filters, things like that. And what's new is you can now have different moduli for the pure austenite phase and the pure martensite phase. So prior to this, when you looked at your stress strain curve, the austenite and the martensite portions of that curve were always, or portions of the stress strain curve were always parallel. And now the slopes can be different. So that just gives us the ability to more accurately capture behaviors for certain types of shape memory alloys.
And that's probably one of those things you may be using code that I won't name on the podcast for, so it's good to have that now in Ansys. Yeah. So yet another reason not to have that one seed of that other code.
Looks like that's supported for axisymmetric and solid 3Ds.
Good, excellent, very good. There's some other kind of less used material modeling stuff that's been added. So definitely take a look at that if that's of interest to you. Here in the desert, we don't do a lot of floating stuff, but Ted, I know that you and some of our other engineers have supported some of our customers in Texas with Aqua. So there's some new stuff.
Yeah, not
right?
just Texas. We've had
right.
The national labs have been using it, and also in California we have a customer that's involved in shipbuilding. And so the project we're talking about is Aqua, Ansys Aqua. So this is a hydrodynamic diffraction code is what it's called, and that's been being integrated into mechanical. And what's new at 2019 R3 is a new Aqua load mapping ACT extension that can handle multiple wave cases. So Aqua itself is used for ocean type loading. So it could be ships, it could be offshore oil rigs, and not just things that are propelled or floating, but it can also handle mooring lines and all sorts of interesting behaviors of things that are floating due to waves and undergoing currents and wind loads and things like that. And so what this extension allows us to do is additional capability within mechanical of using that Aqua tool.
So the transition of the legacy Aqua more and more into mechanical. Yeah.
Right.
Cool. Very neat. I think that I have run out of my list of stuff that I thought was cool. Anything you guys want to add before we wrap it up?
Well, if people haven't used 2019 R2, that was when we had the new ribbon interface added into mechanical.
Big change.
The look and feel is a little different. 2019 R3 still brings up a multiple slide. I don't want to really describe it as a help document, but sort of an assist, a set of steps that assist us. I think you'll find once you start using it, it's very intuitive and user friendly.
Right.
It's not horribly different from what was there before. It's just organized, maybe in the way that we're more used to these days with other tools that we use day to day on our computers.
Yeah, the couple of times that I'm looking for something and I can't find it, I realize, it's right there in front of me.
It's kind of like the ketchup in the refrigerator, yeah.
Yeah, it's like I'll tell myself, why isn't it here? It should be right here, and I'm pointing at the icon.
And I think there were some subtle changes between R2 and R3 in the ribbon interface.
Yeah.
Some things are sticky now that maybe weren't in the first incarnation of it.
And I always like to point out the fact, and this has been very helpful for me as I've wandered my way around the new interface, is in the upper right hand corner, there's a search. Yep. And so if you put in what you're looking for, it'll show it to you where it is in the interface. And I think it's even added some new features at R3 where it shows you stuff that's down in the footer section, not just the menus. So
all right. Very nice.
Yeah, it's a cool thing. Well, there's a lot there. Joe is going to be going through even a subset. We're not going to go through everything, but you're going to find a subset that's a little bit bigger than the one that we just talked about.
Right.
In the next webinar. And when is that webinar? We got that scheduled?
That is next week, November 6th.
November 6th.
I forget what date that is. Wednesday.
It's usually a Wednesday. Yes.
And it's at 11 a.m. Arizona time.
Okay. And daylight savings time kicks in this weekend, correct? So,
well, it ends this weekend.
Or when's this weekend? Thank you.
For those of us that aren't always standard.
That's right.
Right.
For those that don't know, Arizona is one of 2 states in the U.S., Hawaii being the other one, that does not observe daylight savings time because we have plenty. We don't need to save any of it. And
we actually want it to end.
We want it to end. I advocate that we should be on somebody else's time zone so that the sun goes down at like 2:00 in the afternoon.
Well, actually, in the winter is when we should be on daylight savings time.
Exactly.
That's when you want more daylight at the end of the day.
Right.
If I'm ever governor of Arizona, I will do that. I promise. Thank you very much, guys. Lots of cool stuff in there. Always check it out. Always read the release notes if you want to learn more, and never hesitate to reach out to us if you have any questions or anything. Thanks, guys.
Thank you.
Yep. Next time.
Well, thank you for joining us with that. There's a lot. We didn't cover a lot. We covered as much as we could. We went a little long, so I'll go fast through the rest of the podcast. If you want to learn more, do sign up for the webinar, which is on November 6th of next week, which is a Wednesday. Actually, the week that this podcast comes out, it's going to be Wednesday, November 6th at 11 p.m. Phoenix time. And you can always listen to the recording by going to brighttalk.com and searching for PADT and finding the particular one you want to listen to. So you can listen to them live or you can download them later. In the world of Ansys news, we've got 2 really cool stories to report on that I want to share with you guys. Ansys acquired another company called Donardo. They're out of Germany, and they make a product called OptiSlang, which is one of our favorite optimization tools. Maybe our favorite for some of the guys around here. It's a fantastic tool. We always recommend it to customers, and it's great to have them part of the Ansys family. And we look forward to see how that's going to get integrated into all the different products we have. So welcome to Donardo, guys. You were close to the Ansys world already, and now you're even closer. The other thing to report in the world of Ansys news is they opened up a new building with Carnegie Mellon University called Ansys Hall. So you can say, I'm going to go to Ansys Hall and run Ansys. Pretty cool. It's a new building. It's got a big design area, some maker spaces, and they've got access, of course, to Ansys tools throughout. It's a beautiful building on the inside and the out. And do check out the Ansys blog. There's an article about it, as well as press releases everywhere. And this is a great example of Ansys giving back. They invest a lot of money in R&D. They, of course, support education through giving out student licenses and lower cost research and teaching licenses. But this is a direct application to foster future education there in Pittsburgh at Carnegie Mellon University. So a little round of applause for Ansys for doing that. It makes a big difference, and I wish more companies would do so. I kind of skipped over the stock. It's sitting at 220. We did go long. And Ansys, the important thing you need to know is that Ansys is giving out their Q3 data after the market closes on November 6th, which is Wednesday. And then we'll see some changes, hopefully, to the stock. And in our next podcast, we will talk about what they talk about. But until then, there's really nothing to discuss in the world of stocks. So the other thing I want to do is list my 3 favorite blog posts since the last issue of the podcast. The first one yesterday here in the US was Halloween, and some Ansys engineers did a little bit of riff on that. And in the Ansys CFD package, there's something called the mixing template, which is for mixing fluids. You can put a little rotor in there, and basically it builds all that for you and tells you how your different species are going to mix. So they did a story called How to Optimize the Mixing of Your Elixir of Life, and there's some boil, toil and trouble verses in there as well. It's kind of fun. Take a look at that. I learned something totally new in an article called Create and Analyze System Models Using Architecture Analysis and Design Language, or AADL. And I guess that's a way to represent, or I learned that's a way to represent embedded system models when you're building and testing systems. It talks about how Ansys SCADE uses the language to model systems. And even again, like I always say, even if you're doing mechanical or fluids or maybe HFSS, knowing some of the system level stuff is pretty useful because it all starting to plug together. So do check that out. And then the third one that I wanted to point out is keeping with the systems theme. What is reduced order models, and what is a reduced order model, and what's its product development role? I don't know why I'm stumbling over that one. It's a nice little short bit about how to create ROMs, what we call reduced order models, ROMs. Using Design Explorer. And in fact, they're not using mechanical or electrical like you would expect. They're actually using Fluent. They explore a design space. They get a surface, a response surface from exploring that design space. And that turns into basically a lookup table that you can put into a system level model. So do check that out. If you're not doing system level modeling, you should be creating ROMs for people that are, and this is a great introduction to that. Over on the PADT blog, Matt Sutton put out a post for ACT programmers on how to expose information about your custom objects in the details plane in mechanical. So do check that out. It's using the properties class, I think it's called. It's another great Matt article about how to customize Ansys products using ACT, and a big help on how to add things like the name of your coordinate system that you created into the drop down in a details page in mechanical. So check that out. Upcoming events wise, of course, we've got that webinar on the 6th, and do check that out on Ansys Mechanical 2019 R3. Learn more and see the animations yourself. And then we've got a webinar coming up at the end of the month for FlowNex on secondary air system modeling. And those are both available to link to on the Ansys the PADT page at www.padtinc.com/events, and you can click on the information or the registration to get to either of them. And what else is going on in the world of PADT? Well, Rob Rowan, our director of engineering, I don't know that he's been on the podcast before, but he heads up our simulation services group as well as our design group. He and I will be headed over to Long Beach, a part of California that is not on fire, to attend the 2019 Fuel Cell Seminar and Energy Exposition in Long Beach, California. That's November 5th through 7th. And we'll be talking about how we do custom blowers for air and hydrogen in fuel cell applications. And we, of course, use a lot of Ansys, both on the fluids, the mechanical side, and on the electromagnetic side, because we do custom motor design. And we look at all those things that way. We will also be at the 8th Annual American Institute of Aeronautics and Astronautics, the AIAA, Rocky Mountain Sector, their annual technical symposium, which is on the 19th, November 19th this month at the University of Colorado Boulder. And our Colorado team will be there. So if you are a listener and you're in the Colorado area and you're going to go to that AIAA symposium, stop by our booth and say hi to everybody there. We'd love to hear from you and see you. That's it for us for events in the near future. I joked a little bit about the fires in California. It's actually quite horrifying. I do want to reach out to any of our listeners that are caught up in that. We had a couple of employees in California that have been impacted by it. Not too bad, just kind of difficult to breathe. One person got laryngitis from all the smoke. It's bad, and we feel for you. And I don't know what we can do to help, but let us know if we can in any way, shape, or form, at least in the Ansys side of things. Do take care of yourself and be safe. It's a dangerous thing when wind and high temperatures and tinder gets together, fuel gets together. It's not a good thing, so do be safe. Don't forget to subscribe to www.padtinc.com/opt-in and spread the word about the podcast, and don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 50. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.